Today I'm going to be working out of the Unit 9 notes packet, which can be found up on Google Classroom. Today I'm just going to be going through day 1, but what Unit 9 is about, it's about 4 shapes, and the name of these shapes are called conic sections, or sometimes we just call them conics for short. And how they can be formed is if we have a cone shape, and we take a plane and we slice it straight through that cone shape, what we end up with is a circle. So down here at the first bullet point, we can fill in circle, and it says a circle is produced when a plane slices a cone parallel to the cone's base. So that is sliced parallel to the cone's base. If we take the cone and we slice it with a plane, but this time on a diagonal, or here on a diagonal, what it creates when we slice it on a diagonal is it creates an ellipse or a parabola. And we can say an ellipse or parabola is produced when a plane slices a single cone in a way that is not parallel to the cone's base. So not parallel, like on a diagonal. And then for the last conic section, we actually have to have 2 cones. And if we slice it, if we take a plane and we slice it up and down like this, what it creates is a shape called a hyperbola. And a hyperbola is produced when a plane slices through 2 cones connected at their points and the bases are parallel. Okay, so that would create a hyperbola. For today, we are going to discuss circles and parabolas, and we're going to begin with circles at the bottom of the page. So for circles, a couple of key things for circles. One thing we should note is what the standard form of a circle is. The standard form of a circle is x minus h squared plus y minus k squared equals r squared. And that looks pretty confusing. It looks pretty involved. The key thing from here is that the x value is squared and the y value is squared. That's important for a circle. Out here on the end, the r squared, the r stands for the radius. So first thing I'm always going to ask you for a circle is find your center. And the center is going to be whatever h and k is. It's going to be the point h comma k. And then the radius is going to be the square root of whatever term is out here on the end. So let's try one and we'll go through the steps of how we can graph it. So our first example is x squared plus y squared is equal to 36. Now, first thing I notice is that the x is squared and the y is squared. It doesn't have x plus something squared or x minus something squared, and it also doesn't have y plus or minus something squared. So that tells me that the center of this circle is actually 0, 0. It's not shifted anywhere. 36 is on the end. 36 represents r squared, the radius squared, so therefore the radius must be 6. So then I'm going to come over to my graph over here, and before filling out the rest of this, even if you think you might be able to, I'm going to just draw a sketch of what this should look like. So if my center is at 0, 0, I'll put a little dot there at the center, and if my radius is 6, I'm just going to go left 6, 1, 2, 3, 4, 5, 6, all the way to the end, right 6, up 6, and down 6. Those are going to be the key points for my circle, and I will do my best to connect these up into a circular shape. And we've graphed our first circle. The diameter is how far straight across. You might also know that it is double the radius. So if the radius is 6, the diameter is 12. The domain is always your x values. So when I'm looking for my domain, I go along my x-axis and I say how far to the left and how far to the right does this graph go? Well, on the left, remember I was out at -6, and on the right, I'm out at +6. So my domain is -6 to 6. I put it in what's called interval notation. I use a bracket because it includes the -6 and +6. The range are the y values, how low and how high my graph goes. Well, again, it went down to -6 and up to +6. So my range is -6 up to +6. And we've graphed our first circle. Okay, let's flip our paper over and try to look at example number 2. Okay, so number 2, I recognize this also as a circle. I have my x squared and I've got my y squared. And so the center of my circle is supposed to be HK. And what that is, and when it's in the parentheses, you're always going to take the opposite of what it says. So even though it says x plus 2, I'm actually going to take negative 2 as my x coordinate of my center and positive 4 as the y coordinate of my center. Then we've got your radius. Your radius, remember out here, this is r squared. So my radius is going to be the square root of that, or just 4. Okay, let's plot this. So I'm going to come to negative 2, and I'm going to come up 4. And that right there is the center of my circle. My radius is 4, so I'm going to move to the left 4. I'm going to move to the right 4. Down 4 and up 4, and I notice that I actually go off my graph when I'm going up. Connect up and create yourself a circle. Okay, then we've got to figure out what our diameter is. If my radius is 4, my diameter is going to be double that at 8. My domain, again, is always my x's. My range is my y's. So for my domain, I'm going to say how far to the left and how far to the right. Well, this x value goes from negative 6 up to positive 2. And this range value, the y value down here is 0. And my y value up here, I know I went off the graph. The top of the graph was 6, and if I went up 2 more, I'm up at 8. Another way that you can find your domain and your range is you can go from your center, and the x coordinate of my center is negative 2. If I subtract 4, I get negative 6. And if I take negative 2 and I add 4, I get 2. For your range, you can take the y coordinate of your center. 4 minus 4, 0. 4 plus 4, 8. So that's one way you can do it without looking at your graph. All right. Example number 3 is a little bit trickier because it is not in the standard form for a circle. And so what we have to do is we have to complete the square. So let's do a little reminder of how to complete the square. I'm going to group my two terms that have the x's together. I'm going to put those two next to each other. So I'll begin with x squared plus 2x plus blank. I'm going to complete the square with the x's. Then I'm going to put the y terms together. Plus y squared plus 2y plus blank. And then anything else is going to move to the opposite side of the equal sign. So equals negative 1. Now I can't just randomly add these numbers to my equation because that will change my problem. So if I'm adding a number, I need to subtract it. And if I'm adding a number, I don't need to subtract it, I need to add it. If I'm going to add something on the left side of the equal sign, I also need to add it on the right. If I add something on the left, I need to add it on the right. So to figure out how to complete the square, just a little reminder of how we do that. It is always b divided by 2 squared. B is the number that's in front of x or in front of y. Those things that I just underlined are b. So for this problem, if I take 2 and cut it in half, it becomes 1. And if I square it, it becomes 1. So I'm going to add 1. Make sure you add it on the right as well. Then I move here. If I have 2, I cut it in half, it's 1. And square it, it's also 1. Now the purpose of completing the square is so that these three terms right here can factor. They're always going to factor into the same factor twice. And this is going to factor into x plus 1 times x plus 1, or x plus 1 squared. A shortcut for factoring when you've completed the square, it will always factor into half of b. So if b was positive 2, positive 1 goes here. Plus, don't forget we've got these. Those are also going to factor y plus 1 squared. And over here on the right-hand side, 1 minus 1 goes away, and I just have 1. Now this looks more like the form that we were used to looking at. This is what we call standard form. So the center is going to be HK. Opposite of this, opposite of this. So my center is going to be -1, -1. Out here, this represents r squared. And so my radius is going to be the square root of 1, which is just 1. And then let's come over to our graph and take a look. I'm going to start with my center always. So my center is -1, -1 right here. My radius is 1. So from the center, I go up 1, left 1, down 1, right 1. Connect it up, and there is my circle. All right, let's try one more circle. Example 4, we're going to need to do the same thing we did in example 3. We're going to need to complete the square. So I'm going to group together my terms with the x's. X squared plus 12x plus blank. Now I'm going to group together my terms with the y's. Y squared minus 2y plus blank. Bring this constant of 12 over to the right side, so I will now say equals -12. And remember the rule, you can't just randomly add a number to an equation. If I add it on the left, I also need to add it on the right. So there's 2 blanks on the left, 2 blanks on the right. To figure out what value I get, I take b and I cut it in half and I square it. So 12 cut in half is 6. And 6 squared is 36. So 36 will go here. It will also go over here on the right. All right, let's go to the y's. -2 is my b value. I cut it in half, it's -1. And when I square it, it is +1. So I'm going to add a 1 to both sides. And then I'm going to factor. So these first 3 terms factor into something squared. X, remember the shortcut. Take b, cut it in half. So +6 squared plus, I think I was missing a little plus sign here, plus these terms are going to factor into something squared. My b was -2. If I cut it in half, it's -1. So y minus 1 squared equals, over here on the right, I have -12 plus 36 plus 1. That's going to give me a 25. Okay, so now that's in standard form. So now I'm going to pull off my center and my radius. My center is going to be the opposite of the x, comma, the opposite of this y. So -6, comma, +1. My radius is going to be the square root of 25, or 5. And I'll come over here on my graph and graph this. This one I think is going to go off my graph that I'm given. So -6 is way out here. +1, there's my center. My radius is 5, so I'm going to go up 5. 1, 2, 3, 4, 5. Left or right 5. Down 5. And if I went to the left 5, I'm imagining I'm over here. Yes, I am off my graph, but I'm going to connect up and I've got my circle. So I hope that that helps in terms of graphing circles. The next video will be on graphing parabolas.